Hi everyone, it's Math with AUB. As usual, get along for the preparation of SAT, GRE and GMAT. Our question number one reads as an impressive selection. A square with area 84 square units is divided into 4 squares. The upper left square is colored black. The lower right square is again divided into 4 and so on. The process is repeated an infinite number of times for the total area of the colored black squares. We have a square. We have to shed 1/4 of the square. 1/4, 25%. 25%. Again, from these 4 portions, again shed 1/4, again 1/4. That is totals 1/4. That is 1/4 of 1/4. Then 1/4, 1/4 of 1/4, and so on and so on. We and we repeat this process infinite times, continuously, infinite times. We have to tell what is the area of these tiny square that we have formed according to the given condition by shading 1/4 and 1/4, 1/4 of 1/4 of 1/4 of 1/4, and so on up to infinite times. We have to find area of these shaded regions. Overall area we have 84. 84 is the area of this given square. It's given to us. We have to shed 1/4 of this one. 1/4. 84's 1/4. It will become 21. It will become 21. So our first shaded portion is 21. 21. Then we have to take 1/4 of 1/4, 1/4 of 1/4, and so on. And so on. Second one will be 21 upon 4. Another time it will become 21 upon 4 square. Another time 21 upon 4 cube. By continuously multiplying 1/4, multiplying 1/4. Again 21 divided by 4 raised 4, and so on and so on. We have to find their sum. We have to find their sum. Simply, we have given a square having area 84. We have to shed its 1/4. 84, we have just managed its 1/4, that's 21. Again, we have to shed 1/4 of 21, 21 upon 4. Again, we have to shed 1/4 of 21 over 4. It will become 21 over 4 square, and so on up to infinite. If we get a glimpse of this one, it's our infinite geometric sum. Infinite geometric sum that is given by as infinity a over 1 minus r. A the first term, a the first term, a the first term. Common ratio, we obtained each consecutive coming term by multiplying 4, by multiplying 1 over 4, by multiplying 1 over 4, dividing by 4 or multiplying by 1 over 4. So we have a first term is 21, and our constant ratio, common ratio, is 1/4, 1/4. Just plug in the value of a and r. A is 21 and r is 1 over 4. So we have 21 divided by 1 minus 1 upon 4. Taking LCM in the denominator, 4 minus 1 overall 4, shift 4. In the numerator, we have 21 times 4 divided by 4 minus 1, 3. 3 7 the 21. 7 times 4, 28 is our answer. 28 is our answer. If we continue this pattern, taking a square having area 84, shedding its 1/4, again shedding 1/4 of 1/4, again shedding 1/4, 1/4 of 1/4, and so on up to infinite times. That is its sum. That is 28. That is 20. Sum of all these shaded squares. Sum of all these shaded squares up to infinite is 28. It is a wonderful application of mathematics. We can find an infinite sum provided that we have to work within some parameters. For finding its infinite sum, r must be less than 1. Our common ratio whatever thing we are dividing, it must be less than 1. It must be less than 1. Then we are in a position to find its infinite sum. Otherwise, not. In that case, 28 is our answer. Moving towards next question we have. Moving towards question number 2. Let x is equal to pi over 4, pi divided by 4. Which of the following number is the largest? Which of the following number is the largest? A googly type question. X is given to us, that is pi over 4, or pi is traditional irrational number, and it is defined as, the definition of pi is circumference of a circle divided by its diameter. Pi is the common ratio of circumference to diameter. Circumference divided by diameter, that is the definition of pi, and we are familiar, pi is approximately 3.1459. Now look at this. We have given some options. Which one is largest? X4, and then x square, then we have x, root x, and fourth root of x. Fourth root of x. X is equal to pi over 4. X is equal to pi over 4. If you get a glimpse of this one, this is a ratio less than 1. This is less than 1. Value of x is less than, because pi is 3.14 divided by 4. Numerator is less than denominator. Numerator is less than denominator. So we can easily conclude that this ratio, this fraction is less than 1. This fraction is less than 1. This fraction is less than 1. Then x4 is the smallest quantity. X4 is the smallest quantity. And unlike normal, x raised 1 over 4 or fourth root of x is the greatest value, in that case, because whenever we have value of x that lies in that open interval from excluding 0 and 1, excluding 0 and 1, taking these numbers as 0.1, whatever the case is, 0.2, whatever it is, 0.3, and so on, 0.4, whatever the case may be, 0.5, 0.6, 0.7, 0.8, 0.9, whatever the case is. If the value of x lies, if the value of x lies in that interval, then it switched over our mood. Greater quantity will become lesser quantity will become bigger, larger. So in that case, x, fourth root of x is greater than each and every number. This one is the greatest. One can verify by using calculator. I have already shared some. I have solved such type of questions for you in the GRE. That is the magic interval. I call it magic interval. Where mathematics calculation, especially multiplication, is upside down. Normally, that is the greater case in case of positive integers. But whenever value of x lies in that interval, this order changes. It is the greatest quantity. It is the lowest quantity. Moving towards next question, we have question number 3. Moving towards next question. What is the area of the triangle whose vertices are PQ, 3p comma q, and 2p comma 3q, where p, q are both real numbers? Pq greater than 0 means pq are real numbers. Mathematics, especially analytic geometry, especially analytic geometry, thanks to René Descartes, we can solve such type of questions without knowing the kind of the triangle. We can easily manage their area. Its area is given by 1 over 2 for half. Taking the coordinates p, q, 1, expanding this determinant, second coordinate is 3p, q, and 1, and this next one is 2p, 3q, and 1. Expanding this, 1 over 2, keep it intact. Taking this, positive, according to Laplacian expansion of the determinant, p, deleting first row and first column, we have a tiny denominator of 2 by 2, that is q1, 3q1. Second, negative q. Now excluding same row first, now second column, we have a tiny determinant left of 2 by 2, that is 3p1 and 2p1 plus 1. Now deleting same row first and third column, now we have tiny determinant of 2 by 2 left, 3pq, 2p, and 3q. Okay, expanding them, q times 1 minus 3 times q. 1 over 2 half same p. That is 1 times q minus 3 times q. 3q times 1, that's 3q. Negative q. We have 3p times 1, 3p. Negative 2p times 1, it's 2p plus 1 as usual. We have, it will become 9pq multiply minus 2pq. Simply simplify them. Positive q minus 2q, positive q minus 3q, positive q minus 3q. We have negative 2q multiplying with the 2, it will become a negative 2pq. And this one only p is left, 3p minus p times q, it's negative pq. 9pq minus 2pq, that's our 7pq. Minus 2 and minus 1, it will become minus 3. Minus 2pq minus 1pq minus 3pq plus 4pq plus 7pq. Minus 2pq minus 1pq plus 7pq. We are left with 4pq. Applying table. 2pq square units is the area of that triangle. Option number C is the right option. Moving towards next question, we have question number 4, that demands from us how many 3-digit numbers formed using only the digits 1, 3, 5 are divisible by 3. You may use digits more than once, means repetition is allowed. 3-digit number, we are asked to find how many digit number? 3-digit numbers using the digits 1, 3, 5. Repetition is allowed. Repetition is allowed. Repetition is allowed. And second condition, the foremost condition is that our number must be divisible by 3. Our number must be divisible by 3. Our number must be divisible by 3. Look at the beauty of these 3 digits. Add them up. 1 plus 3 plus 5. They add up to 9. 9 is divisible by 3. 9 is divisible by 3. So, using all these digits once and only once always gives us a number that is divisible by 3. That is divisible by 3. We are asked to find how many 3-digit numbers are possibly formed by using the digit 1, 3, 5. Even repetition is allowed. Repetition is allowed. That must be divisible by 3. We add them up. All the 3 digits 1 plus 3 plus 5, they are 9. 9 divided by 9 is divisible by 3. So all the digits that are formed by using one exactly one time all these digits gives us a number that is divisible by 3. So all possibilities are in that case is 1, 3, 5. Keep 1 intact, shuffle them up. 5, 3, 1. Now keep intact 3, 1, 5. Shuffle 1, 5 among between them. It will become 3, 5, 1. Next, take 5 at the foremost position. Then shuffle 1 and 3. It will become 3, 1. These are the 6 possibilities according to our simple idea. For first number, we have 3 possibilities if we are using them once. For second digit, 2 choices. For third one, or 3 factorial, it is equal to 6. It's equal to 6. All these are the numbers that add up to 9 that we have done. It is divisible by 3. It is also divisible by 3. 80 is also divisible by 3. So does this. And so do all these, both of these. 5, 3. So these are 6 are the possibilities that are divisible by 6. We have been given a free hand that we can use each digit more than once. Each digit more than once. There's another possibility props up, that is, if we take all the digits same 1, 1, 1 or 3, 3, 3, 5, 5, 5. Sum of the digit is 3, it's divisible by 3. Sum of digit is 9, it is divisible by 3. It is also divisible by 3. 5 plus 5, it is 15. 15 is divisible by 3. It is also divisible by 3. So 6 plus 3, 9 are the possibilities. 9 are the total possibilities of making 3-digit number using 1, 3, 5. Even repetition is allowed and divisible by 3. If we repeat one more than once, it gives us a number that is not divisible by 3. Look at this. 1, 1, you can take 3, or 1, 1, you can take 5. These are the numbers that are not divisible by 3. So does, if you repeat 3, use once, or 3, use 5, Sum of the digits 7, it is not divisible by 3. Sum of digits 11, it is not divisible by 3. So we have total 9 possibilities. Of them, 6 are the possibilities when each digit is used once. That simple factorial idea that we have discussed, 3 factorial 2, 1. For first, using first digit, we have 3 possibilities, for second 2, and if we take all the digits in triple 1, triple 3, triple 5, these are the digits that are also divisible by 3. So 6 plus 3, 9 are the possibilities of the digits. They are also divisible by 3. They give us a number, gives all the numbers that are divisible by 3. If we repeat one more than once, it gives us a number that is not divisible by 3. If we double 3 anywhere in any position, it will give us a number that is not divisible by 3. So does 5. If we write 5 more than once, two times, it will give us a number that is not divisible by 3. See you in the next frame.